All right, thanks everybody. My name is Jerry Hargrove. I'm going to talk today about from zero to DevSecOps in 60 minutes. Now, obviously, I don't have 60 minutes to give this talk, so I'm going to expedite some of it. I'm a solutions architect at Rackspace, so I work with a lot of customers who are building out new infrastructure in the cloud, in particular AWS. You can see my Twitter handle is AWS Geek. My website is awsgeek.com, so you can tell what kind of background I have. So, and I don't have a picture of me up here. You'll see a picture of me in just a few minutes. I'll put one up there for reference. But today what I'm going to talk about is DevSecOps and getting there very quickly. So my background is as a developer. So I was happy to see that there were probably about 50% of the people in here who raised their hand when the question was raised previously, who's a developer? Then I also saw that when the break come, about half the people in the room just left their laptops sitting on their desk and walked away, and the other half packed them up and secured them. So I'm not sure which half did what, but I'm assuming it was us developers who just left our stuff sitting out. So I'm going to talk about, I have a particular perspective I'm looking at today. I'm going to go a little bit deeper than some of the previous talks. So I'm going to talk less about the why and the what and the who and the when, although I am going to cover those briefly, and more about how. So a very practical or pragmatic approach to DevSecOps, in particular for those of you who are working in the cloud. This is based on my experience that I've had with AWS customers as well as Azure and GCP. So before we get started though, quick show of hands. How many of you are building or securing applications in the public cloud? So we've got about 50% of you. How many of you are doing this in a private cloud? And how many of you on-premise, no cloud at all? So we've got a few. So mostly public-private cloud. So most of my discussion today, obviously AWS Geek, awsgeek.com, I'm going to be talking about AWS and practical application of that. But as I mentioned, I'm not going to leave out Azure or GCP. I'll talk about them too and give you some equivalent examples on all of those platforms. So let's go ahead and get started. So the question about when comes up, about when should we be doing this. Obviously, we should be doing this yesterday. We should all be worried about security and DevSecOps in general before today. But I wanted to give you an example here. How many of you are familiar with this company, CodeSpaces? Anybody? Anybody actually work for CodeSpaces or worked for them? CodeSpaces was a cloud-based company a few years ago. They opened their doors. They provided services for companies, hosting code and project management. One day, CodeSpaces customers woke up to this message, and it was CodeSpaces is down. And you probably can't see all the detail in that message, but effectively what the message was is someone gained access to our account credentials, got into our AWS account, and started deleting our customers' data, and then getting rid of S3 buckets and destroying our databases. And before CodeSpaces could react, they didn't have some best practices in place to protect this. Before they could react, CodeSpaces put this next sign up. So they were unable to recover from this. They didn't have multiple backups. They didn't have backups with different vendors in different locations. They were unable to recover from this. They were unable to recover technically because they lost data, and they also lost the trust of their customers. And so my point of this is, coming from a development background or a developer's background, I often think, well, we're just being paranoid. But just because you're being paranoid doesn't mean there's actually not somebody there actually coming after you. So it's good to look over your shoulder. If you are familiar with AWS and S3, you've probably seen some of these next. Get a little bit of a delay here. Actually, this has got a lot of graphics in it, so maybe that's the. Okay, so if you're familiar with AWS, you've probably seen or come across some of these news articles recently about AWS users and S3 buckets and leaving S3 buckets publicly open and available. So either AWS users have created public buckets that they're using for websites, which is perfectly acceptable, but then inadvertently stored sensitive information in them, or they have a private bucket that they're using and storing sensitive information in, and inadvertently someone makes it public. And so we see these stories quite often. Actually, just in the last week, that last one with FedEx was just a few days before I came here. And so these types of incidents and breaches are actively going on. And so the next question comes up is why? Well, some of this goes back to the discussions we were having this morning about increased security exposure through the evolution of our software and best practices. And for many of you who have been around for some time, and it's been mentioned this morning, that many of our systems have evolved, whether it's architecture, moving from monolithic systems to service-oriented end-tier architectures to microarchitectures, or whether it's actual systems, going from bare metal systems in our back room to VMs to containers to functions. And our methodologies, waterfall, agile, CI/CD. All of those have allowed us to progress and deliver software to our customers much more quickly than we were able to before, say 20 years ago. Back when I started writing software, we burnt software to a CD, we sent it off to a manufacturer, they mass reproduced it, we got someone to print the manuals, we put it all into a box, we shrink wrapped it, we put it onto a truck, and then shipped it out to a store. This took 6 months, 9 months, 12 months, so there was really no rush for security to get involved then. Today, though, we can actually turn software around in a matter of minutes. And so as mentioned earlier, with that type of speed, some level of automation needs to be in place. And I spend a whole lot of time on this, but anytime we talk about, well, DevOps in general, we talk about people, process, and tools. And the same applies to DevSecOps. The same fundamental changes need to happen. As a matter of fact, I think if you're not already implementing or have some form of DevOps culture in place, that it can be very difficult to automatically move to DevSecOps. So what I'm going to talk about today is mainly on the right-hand side of that screen, so mainly automation and tools. We've come to a point now in software, especially when we look at microservices architectures, container-based architectures, the complexity of these systems are such now that we can no longer do this without automation. And so we look at what types of things to automate. I'll just iterate over a couple of these real quickly. Auditing of systems, what kind of systems that we have out there, what's in place, what our response is going to be, so automating responses, in particular in the cloud. We mentioned earlier about containers, how many systems are ephemeral now. I mean, just in the cloud in general, our systems are ephemeral, and so we need to be prepared to deal with them in a way that doesn't involve actual manual intervention. Analysis of systems, so looking at forensics and log diving, these are all candidates for automation, remediation, as well as reporting. Now I'm going to talk a little bit about sort of response and isolation and things like isolation and tagging, more post-activity than pre-activity. There are a lot of different ways to approach this in the cloud. I'm going to focus mainly on things that we can do after the fact, detecting that something has occurred. There are ways and methods of preventing these activities from occurring. That's a completely different discussion about identity and access management, roles and responsibilities, users and roles on your cloud provider. But where you guys start ultimately depends on you and your system and your team. What your budget is, these were talked about earlier today, what your schedule is, what skill set your team has, how risk averse you are, what type of risk you're able to take on, and your priorities, and then ultimately the culture of your system. The next thing I want to cover real quickly is who. But before I do that, I usually never do this, but I want to call something out that this week is actually my 30th anniversary, and my wife, who never comes to these conferences, is sitting right back over there in the maroon dress. We were here Just a few seconds ago, I leaned over to her and said, we've been married 30 years. I've embarrassed you a lot. Is there anything that I couldn't do that you wouldn't be embarrassed? She said, no, I've seen it all. So we were actually here 30 years ago in Singapore, and now we're here. We both look exactly like that, too. We have not changed a bit. So I'm sorry, dear. I really wanted to do this in public, too, because you know that if no one sees me after today, what happened? So the who is really about my wife and I, but the team. Whether you have a veritable army of roles or actual people associated with security on your team, or you're an army of one, ultimately it all boils down to your business. What we do as developers and what we do as security experts affects everybody in our business and in our company. Like with the CodeSpaces example, yes, there were some security issues, there were probably some development issues, but really it took the company down. It wasn't just the developers and the security team that was affected. So I have a couple of sort of stopping points along the way today where I put up questions that really matter, for me to catch my breath, and if you have any questions while we're going. We could probably take time to answer a question or two. If you don't have any, that's fine. I'll just roll right through it. No questions? So I'll go ahead and keep on going. Again, it's an opportunity for me to catch my breath, grab a drink, and if you have any questions along the way. So this is really what I came here to talk about today, and sort of the meat of this discussion, and that is, how do you do some of these things in the cloud, and specifically on AWS. So I'm going to give you some examples, talk about some services today. I'm going to go probably another level deeper. We're not going to write code. I'm not going to give any demos, but I am going to give you some ideas for things that you could do when you leave here today. Ultimately, the call to action at the end of this is that you have enough information to go out and make changes in your environment or do something that you might not already be doing. So this probably dates me too. How many of you remember the Gang of Four and design patterns? All right, I don't feel too old. Mid-90s. So design patterns in software development are a way for us to sort of amortize the cost of certain activities or code. It allows us to speak a similar language when we're talking about specific problems. So if we're having to redo things over and over and over, we can build a design pattern around it. So when I talk to somebody about a visitor pattern or a facade pattern in software development, if they're familiar with the Gang of Four book, we can talk the same language. And so today what I'm going to introduce is a simple design pattern. Many of you are probably already familiar with this. It's event-driven software, and I'm going to introduce that in the context of security and adding some automation to our environments. So event-driven software is really similar. You may be familiar with it. Maybe it's called PubSub, or you may have some other name for it. Really, it involves three different components, right? A producer, a channel, or a consumer, and these may be called different names depending on where you work. They might be called subscribers and publishers, event managers, etc. Ultimately, though, it does really interesting in software. It allows us to decouple one end from the other. And that means that we can vary both of those. So if you think about microservices architectures, that's a lot of what that's about, is decoupling these components so they can vary from one another. So you can have different development teams, different languages, they can scale differently. So in event-driven software, imagine an event or a message occurs at one end, the producer produces it, hands it off to a channel. The nice thing about this is the producer doesn't need to know about the consumer on the other end. So it doesn't have to worry about subscriptions, doesn't have to worry about retries, doesn't have to worry about exponential backoffs in case of failure. The channel manager or the event manager handles that and can deliver that to the customer or the consumer. So the consumer can subscribe to producer events very easily. This also means that it's super easy to broadcast that out to multiple consumers. Again, the producer doesn't have to worry about any of the details of that. And this translates very well to event-driven security. We can use this same type of model in public cloud. And as a matter of fact, the cloud providers all provide infrastructure that allows us to do this very easily. So in an event-driven security model, say, for example, we wanted to do something like this on AWS. What are some of the components that we use? So on the producer side, AWS provides a whole laundry list of event producers. If you're familiar with AWS services, you probably recognize some of these. All of these can become part of an event-driven security system and produce events that you can act on. One in particular that I'm going to spend some time on today is AWS CloudTrail. So for the AWS users in the house, how many of you are familiar with CloudTrail? Familiarity with it, good. So I'll talk about it briefly. I won't go into a whole lot of detail. That's really not the point of this session, but just to get you somewhat familiar with it for those of you who aren't familiar with AWS. So all interaction with AWS, or for that matter, GCP or Azure, ultimately goes through an API. So you're making an API call to individual servers or services within that cloud platform. In AWS specifically, whether you log into an AWS console online through your web browser, or you write an application that uses one of the AWS SDKs, you've got a Ruby app, or you've got a Go app, or what have you, or using the AWS command line interface. Any calls into the AWS system that interact with your resource go through, it results in an HTTP request that then goes through API. CloudTrail is responsible for capturing all of those API events in AWS. So you can imagine this big bubble around all of your AWS infrastructure. For anybody to gain access to it or make any changes to it, they have to make an API call. CloudTrail is there to capture that. Now, so just kind of walking through what happens. A user logs in, say, to the console. They make a change. They go to an S3 bucket and change the permissions on it. That ultimately results in a call to an AWS API. That event, that API call, along with metadata associated with that call, is captured by CloudTrail. CloudTrail then takes all of that information and aggregates it all up into a log file and pushes it over to an S3 bucket. It's important to point out here that this is not a real-time activity. This is very commonly used on AWS for doing forensic analysis of events or something after the fact. This can take on the order of minutes to get that information into S3. Once it's in S3, anybody not familiar with S3? I should ask that question first. I sometimes assume. So it's AWS's object storage system in the cloud. Once it's there, though, you can use other AWS services like Athena, like Macie, Redshift, all of those to actually look at that data and look at those log files and start doing forensic analysis or extracting information from it. A CloudTrail event itself might include information like this. That information includes the event source, so what service generated this event, in this case EC2, Elastic Cloud Compute. The event name was start instances, so someone tried to launch an EC2 instance in the cloud, and there's the region it came from and the source IP address of the person who initiated the request. Now, there's a lot more information than that included in an event, but just to give you an example of what one looks like. JSON data structure, very straightforward and simple to process. So now that we have a producer identified in the form of AWS CloudTrail, let's look at what sort of the channel is on AWS. On AWS, that channel is AWS CloudWatch events. So that's that component that sits in the middle of producers and consumers, manages ingestion of events, manages subscriptions by consumers, and then delivers that event down to those consumers. So near real-time event stream. I call that out because none of this is actual real-time. That this is an asynchronous operation. This can happen much quicker than pushing it to an S3 bucket and reading it after the fact, but this gives you much closer to real-time than any other message. So AWS CloudWatch events routes those events to the subscribers to it. And as I mentioned previously, you can have one or more or multiple subscribers to these events. So if you wanted to daisy chain or do things in parallel based on a particular activity in your system, you can do that using CloudWatch events. And just a little more detail to the previous slide about what's included in a CloudWatch event. Here's another example, some generic information that's included in all of them. For example, the account ID, the username associated with it. So you can imagine using this information to go in and say, give me a list of all of the API calls made by Jerry over the last 24 hours. So it gives you a real keen insight into what's going on in your system and what a particular user or users have been doing. So that was pretty straightforward. We've got CloudTrail set up on AWS. We're now going to use CloudWatch events. So when CloudTrail produces an event, we're going to set CloudWatch events up. CloudWatch events allows you to filter and say, okay, I want this particular service, and I want this particular API. I want that to trigger an event. So what's actually going to consume those events? Who's the consumer on the right-hand side on AWS? Another laundry list of AWS services that can consume these events. You may recognize many of these: Kinesis, EC2, Code Build, step functions. You can send this off to any of these services to do a lot of different things. If you just want to send a notification out, you can use simple notification service. If you want to queue events up in a queue for later processing, you can do that. One of the things that's super interesting in an event-driven architecture is AWS Lambda. So AWS Lambda is AWS's functions as a service offering. So it facilitates serverless computing, allows you to very easily write code and have it executed when you want it executed, but you don't have to deal with all the overhead of spinning up a VM or an EC2 instance, maintaining the operating system. It simply executes your code in response to an event, and you only pay for that when your code is running, as opposed to spinning up an EC2 instance and sending all these events to you. You're paying for that EC2 instance as long as it's up and running. Serverless computing allows you to only execute code and be charged for it when that code is actually running. All right, so that was easy. AWS, we've now got CloudTrail generating events. We've got CloudWatch events, taking those events, filtering them, and then forwarding them off to consumers, in this case, AWS Lambda. So that's our AWS version of a simple event-driven security system, and the one that I'm going to use to show a couple of examples going forward. Before I do that, again, if anybody has any questions or comments, happy to field a couple of short ones now if you have them. Raise your hand if you do. Go ahead, and we'll bring a mic over to you. Okay, go ahead. I didn't hear you very well, so you might have to use the mic. Sorry.
I was just going to ask, it looks like a lot of setup based on the number of tools you presented and the number of different types of events you'll have to process. Would your recommendation be to use a tool on top of these event streams?
You definitely could. I think that once you grow beyond a couple of simple events that you want to handle, you may want to have something else in place to orchestrate all of those. And there actually may be tools that do some of this out there already. But I could definitely see, as it becomes more complex, beyond looking for the couple of examples that I'm going to show today, then it becomes just managing all of that infrastructure. And again, having a tool or some way to automate management of that is going to be beneficial. So I think the answer is yes, once you grow beyond the simple examples.
All right, cool, thanks.
All right, thanks. Any others? All right, so let's actually walk through an example. And here's a simple example, really a real clear specification. Notify somebody when CloudTrail logging is disabled. Now there's some context here that I want to give to you. CloudTrail is this service that we're going to be using that's capturing API calls on AWS. CloudTrail hasn't always existed. As a matter of fact, it was only introduced on AWS just a couple of years ago. And by default, it is off. And so it's super important, and because CloudTrail is so useful in any type of security system that you're building, that CloudTrail actually be up and running. Now, the reason AWS doesn't turn it on, I should say, doesn't turn it on by default for accounts is just for backwards compatibility. For new accounts, new AWS accounts that are created as of probably 6 months ago, it's turned on by default. But users still have the ability to turn it off. And so one of the things that we want to protect against someone coming in and disabling our prime method for gathering security information, API calls. Now, obviously, as I mentioned before, the first way is to prevent it from happening in the first place. So setting up users and roles, identity and access management, using that to establish least privileges so that people can't actually turn it off. But you may have a case where you need to have somebody with that permission and you want to be notified when they do it. So let's look at an example that shows how to use the system to do that. All right, so walking through this, step one, a user logs into the system. That could be an actual user going through a UI, or it could be an application with a set of credentials that has access to this system. That interaction with the CloudTrail API, so that user is going to actually go to the CloudTrail service and say, execute the stop logging function. That interaction with CloudTrail is going to be captured by CloudTrail itself. So CloudTrail is going to capture that event and then is going to send it off to CloudWatch events because we have set up a CloudWatch event source. And this is probably a little hard for you guys in the back of the room to see, but setting up a CloudWatch event source is really as simple as saying, okay, I want to watch for events associated with the CloudTrail service in this case, and specifically, I want to be notified when someone executes the stop logging functions. You see at the bottom of that section A there, we've set that up. Next, once that event is captured by CloudWatch events, we want to execute a Lambda function. And I've got a real quick sample of a Lambda function here. It could be really as simple as this. Here's a Python function that gets executed each time one of those events occurs. And you can see at the top of the function, I'm grabbing some information out of the event, in this case, just the region. And I want to put that into a message and send it off to a Slack channel, for example. And so this could be as simple as it is, right? We want to do this one thing and we want to do it well. We're going to send it off to a Slack channel and notify somebody. So once we've got that, then we go back into our CloudWatch events. We've set up the source of the event. Now we want to set up a target. And again, probably a little small for you guys in the back, but setting up a target is really just a case of selecting that Lambda function that exists and saying whenever this source event occurs, send that event to this Lambda function. And you can send the event in a couple of different forms depending on what you're going to do. Ultimately, though, you can send the entire event, the entire JSON data structure, and your Lambda function can do what it would like with that, extract whatever information. Now, I go in, or my user or application goes into the CloudTrail, so sort of stepping back in time a bit, and disables CloudTrail. I went through the UI here. That then triggers the function. We walk all the way through the chain. It triggers the Lambda function. The Lambda function gathers all the information from the event, packages up a message to send to our Slack channel, and voila, there, we see this in our Slack channel. Hey, somebody disabled CloudTrail in US West 2. And I did just a simple example here just to demonstrate how you could do it. It's not any more difficult than that. You could package up whatever information you wanted. You might need to go out and pull in some context about the event, some metadata about the event, but this is really a real simple example just to demonstrate how you would do it. I mentioned earlier the use of simple notification service as one of the targets for an event. And simple notification service is a pub sub messaging service provided by AWS. In my developer, so right now I work as a solutions architect now. As a developer, I worked at AWS, and this is the service that I worked on. So it allows you to do pub/sub messaging, so you can set up topics, you can have individual endpoints that subscribe to these topics, you can do massive fan-outs with this service, mobile notifications, etc. But it's also another interesting way to capture events and send them out. So we change our event-driven security architecture just slightly, replacing Lambda on the right side with Amazon SNS. And then we walk through almost exactly the same steps as we did before. And you'll see this pattern occur in a couple slides again. So it's very similar regardless of where we're doing this. So again, we go in, we set up an event source for CloudWatch events, configure it with the same event information. Then we want to send it off to SNS. So we go back to CloudWatch events. We set up a target. In this case, instead of it being a Lambda function, now we specify an SNS topic. I took some of the event and pulled out, in this case, the user and the region. And I'm going to send out a simple notification via email to whoever subscribes to this event saying, hey, Jerry disabled CloudTrail in this specific in this region. So go back, disable CloudTrail through the console or through the API, and an email gets generated. SNS is notified with that event. It pulls that information out, packages it up into an email, and in a matter of seconds, I get an email notification in my inbox. Jerry has disabled this region. So I'll stop right there. That's a quick example of what you can do on AWS with CloudTrail, with CloudWatch events, and with Lambda. Anybody have any questions or comments? Anybody actually tried or done any of this before? All right, I don't see any, so we're going to go ahead and roll right through. So this is what our event-driven security architecture looks like on AWS. It's CloudTrail, it's CloudWatch events, it's AWS Lambda. This is a pretty well-proven architecture. I've used it. Other AWS users that I've worked with have used this simple architecture. It turns out that all of the cloud providers provide similar services. They've matured to the point, and when I say all, I mean the top 3 or 4. If you include AWS, GCP, Azure, Alibaba to some extent. All of them provide these basic services and functionality that allow us to very easily build the same architecture out regardless of what public cloud that we're on. If we look at GCP, Google Cloud, they provide a similar set of services to the ones that I described. As opposed to CloudTrail, we have stack driver login, where we can extract API calls and information about user interaction with the system. We can set up Cloud PubSub to establish it acts as the manager in the center, so it will manage all of the subscriptions, ensure events are delivered to consumers. And then we have Cloud Functions, so that's GCP's functions as a service offering. And the architecture then, it's almost as though I just replaced icons and names in here, because that's exactly what I did. It looks and behaves almost exactly the same on GCP as it does on AWS. You have stack driver logging acting as the producer. You have Cloud PubSub acting as the channel, and ultimately Cloud Functions as the consumer. So in this generic architecture, it looks very much the same. So let's look at a quick example using GCP then. So going back to our first example, let's send a Slack message when an event occurs using GCP. Now this is a little bit different than the AWS example. In the AWS example, I wanted to know specifically when a user had disabled CloudTrail. Well, there's no CloudTrail in GCP. As a matter of fact, you don't have the ability to turn off stack driver logging. So this is just a generic event on GCP, how you would do that. It turns out it's almost exactly the same as on AWS. So a user interacts with the system, one of the Google Cloud APIs, that in turn generates an event of some form that is captured by stack driver logging. We can set up filters that then send filtered events and messages to Cloud PubSub. Cloud PubSub, then you can configure to deliver these messages to consumers. In our case, we're going to deliver it to Cloud Functions. Ultimately, then we can do whatever we'd like there. Sending messages is a simple example. You can send this notification out to your existing applications or software, whether they're on-premise or off-premise, in the cloud or off the cloud. You can send it wherever you'd like. In our case, I just wrote a quick JavaScript function that did a notification to a Slack channel, exactly the same on AWS. So you get the same types of information and can send the same types of notifications out regardless of the platform that you're on, or execute the same, execute arbitrary code in response to a particular function. So end to end, it looks like this. Cloud API, stack driver logging, Cloud PubSub, Cloud Functions to Slack. This is the GCP version of what I described earlier in event-driven security for AWS. So it looks exactly the same, just the names have been changed. Now, if we go to Azure, we see something very similar. Very similar services, very similar functionality. Instead of stack driver logging or CloudTrail, now we have Azure Resource Manager, which is what you interact with to administer your resources in Azure, and that captures those activities that you take with it. You can then pipe those activities over to Azure Event Grid. This is something that's actually new in the last couple of months with Microsoft, but it helps glue all of this together. You can do PubSub, you can do fan out, whatever you'd like with Azure Event Grid. So you can send those events from Resource Manager, Event Grid, set up subscriptions to Event Grid, and then send all of that out. And then you have Azure Functions, which allow you to execute code in response to an event. Again, very similar. So similar that I'm going to show you this, the high-level model. I'm not going to walk through another example because they all end up being very similar. There may be specific events or events that are particular to the platform that you're on, whether it's AWS or GCP or Azure, but it all looks very similar. So before I go on, I've got another example I wanted to show real quickly, but any questions or comments at this point? I can probably answer one or two on the way. All right, cool. We'll go right through it. So early on, one of the things I showed was S3. So this is a particular pain point with me in that in order for these stories about S3 to occur, someone has had to have done something or taken some action to make their S3 buckets publicly available or changed an attribute on them. And it's very simple for you to detect, number one, that that's occurred and then take some action using this simple architecture that I've shown today. And so really it looks just like this. It's very similar to what we've already talked about. On AWS, someone interacts with an S3 bucket or an object in an S3 bucket. Ultimately, they're going to call the put object or put object ACL API calls on S3. That is captured by AWS CloudTrail. So anytime anybody interacts with those services, CloudTrail captures it. We can set up CloudWatch events specific to that S3 bucket, can be specific to resources within that bucket, and have it trigger an AWS Lambda function. Just like the other examples, it's exactly the same. The configuration is the same. The details about what you want to do are what ultimately is different. So in this case, we could actually tell AWS Lambda to take that API call, if it's in a bucket of interest, to reset the permissions on it such that it's not publicly available, and then potentially notify somebody. Again, this is happening after the fact, so it's reactive. You'd still want to put other practices in place to prevent somebody from doing this initially, but I think more often than not, this is happening accidentally. Someone with permissions is making the change, exposing the bucket, or they're putting an object into a bucket that shouldn't have been there anyway. So to kind of step back and give you sort of a big picture, I wanted to stop and summarize here and go over the things that we've talked about. So event-driven security, on this slide I show all of the different permutations of it, depending on whether you're on AWS or whether you're on GCP or whether you're on Azure. Each of the cloud platforms, public cloud platforms, has similar infrastructure and similar services that allow you to do very similar things on them. They've all matured to a point now where you can actually do these very simply. No longer do we have to poll for events. Prior to these services being in place, it was common to see us polling for activity in our public cloud, and then once we saw an activity occur, taking some action based on that. Now all of the cloud providers provide some form of event source that allow us to react to these changes, and we can use these services that I've described here. Stepping up and looking at what we talked about, this is really the high-level view of the activity that I walked through today. Users interact, and specific to AWS, users interact with AWS through an API of one form or another. Every interaction goes through an API. That API can be captured by AWS CloudTrail. You can do a couple of things with CloudTrail. You can, by default, that information goes through an S3 bucket. I didn't talk a lot about what you can do there, but other than to mention, there are a lot of tools and services that you can use on AWS to actually mine data out of that bucket. Who's been using what APIs? You can run it through machine learning. You can do all kinds of AI on that information to mine data out of it. You can use tools like Macie or Redshift. But you can also send that information and set up custom activities based on those events. So we set up CloudWatch events to filter these activities, and then we set up consumers of those events, whether it's SNS to send out simple notifications when an event occurs, or Lambda to execute code when execute custom sets of code to interact with internal or external systems. This is a super flexible system that allows you to really get your feet wet really quickly and is really easy to set up. So to close, I want to leave you with a couple of items. Number one, for those of you who are AWS consumers, and I don't think I broke it out. How many of you, of those who are in public cloud, how many of you are using AWS? How about GCP, Google? How about Azure? So that's roughly what I would typically see. You know, the majority using AWS, then GCP, and then Azure, but it really varies greatly. If you're using AWS, then this is really for you. If there's one thing you take out of this talk today, is go back to your office and make sure CloudTrail is enabled. If it's not enabled on your AWS account and a breach occurs, then you really have no effective way of doing forensic analysis on this unless you have some other system already set up. Number two, based on what's been in the news lately, again, this is specific to AWS, go back and check your S3 buckets. Really make sure that if you have a public S3 bucket, and there are lots of reasons to have public S3 buckets, if you're hosting a static website, put it in an S3 bucket and make it public. You have to do that. But make sure that you're not storing sensitive information in that bucket. Also look at buckets that are designated as public and make sure that you're not storing sensitive information in there. Third, regardless of what platform you're on, even if you're not in a public cloud, start looking at building out an event-driven security framework. This allows you to begin automating some of your infrastructure. And it makes a leap for many companies, especially those who have an army of one focused on security, to jump in and start automating some of this infrastructure. Finally, and this is my hope that after this conference, I don't have to update that slide with new news stories. Stay out of the news. This is really the big one because it's as soon as there's an S3 bucket that's exposed, it ends up in the news, and I don't want to update that slide anymore. So that's it for me today. I appreciate all of you coming and sitting through this talk, the questions, and I'd like to open it up now. I don't know how much time we've got left. 1 minute?
1 minute.
Okay, so Anybody have any questions on what I presented today? Any comments? You're using it already. Great stuff. Raise your hand. We'll bring a mic over to you. I don't see any. Oh, I saw one right here.
So it's a no-brainer if you don't secure your S3 buckets, right, as you've shown. So can you give an example of the scale at which you're running these queries, probably, the events which you mentioned?
I mean,
rack space or anything. How are you managing the notifications? Let's say if you have a big infrastructure, you're bound to get a lot of noise, and then how you are managing that noise versus
yeah, so this kind of goes back to an earlier question, I think, where it's once you get to scale, this works for sort of that one-off, let's get our feet wet. But once you get up to scale, then you have to have infrastructure around that to start managing it. And you're right, dealing with false positives, all of the same types of topics that you would deal with normally. So this allows you to get in there and start experimenting with it and start using it. And what I've found and where I most often see this type of architecture is when I'm working with AWS customers who just don't have anything in place, right? It's like, I don't have anything. I can barely secure my application. Now you want me to secure my infrastructure as well? So this at least gets them moving in that direction. But you're absolutely right. Once this scales out, you have to have some sort of infrastructure or some sort of tooling in place to manage all of that. Any other questions? Well, I'd like to thank everybody who came. I'd like to thank my wife for putting up with me. And thank all of you and the presenters. Thanks.